Hello class, and welcome to Unit 5. We're taking a look at polynomials this unit. So first thing we're going to do is take a look at lesson 5.1, identifying polynomial functions. Let's go over some terminology. Most of this should be a review from grade 11, but again, some might be new for you. First terminology is the degree of a function is where you take a look at the greatest power of x. So looking in this first example, I notice I've got an x to the power of 3, x to the power of 2, x to the power of 1. And just remember, guys, that this is really x to the power of 0, because anything x to the power of 0 equals 1. Okay? And so when you take a look at the exponents, the one with the highest exponent, so that means 3. Okay, so look for the highest exponent. Okay, second example, we've got to the exponent 6, 5, 4, 3, 2, 1, and that's really exponent 0, x to the exponent 0. Okay, and we're looking at the highest degree, and it's 6. Usually when you display polynomials or expressions, you always put them in the highest power first. That's so that you can easily identify where the degree of the function is. Another piece of common terminology is called the leading coefficient of a function. And that's the coefficient of the term which has the highest degree. Okay, so in the examples above, you look for the leading coefficient. Now, first of all, this was degree of 3, so we look at this term. Okay, and the coefficient is the number that's attached to the variable. So for the example for A, the leading coefficient in this case would be 8. And for example, B, again, we had the highest power exponent of 6, so you look at the coefficient, it's negative 13, and the sign always plays a role with that as well. Okay? All right, next moving on here, we notice that we've got exponents of 0 means that the term is constant. Okay, so if I go back up to that example where it says negative 12 in B, that is really negative 12 times x to the exponent 0. And remember, anything raised to the exponent 0 equals 1. So that's where you get the negative 12. Okay? Now, an important definition that might be new is the polynomial function. What we need to know is that it has exponents which are whole numbers. Whole numbers means that they start with 0 and they go on. There are no fractions, no decimals, and no negatives. So you can't say that they're integers, because integers also allows for negative numbers. So you have to say they are whole numbers. So that's to keep in mind. Let's move on a little bit more and talk about functions. Okay, a function is a relation between a series of pairs of numbers where each x variable or the independent variable is associated with only one y variable. The common terminology I like to use is each x has only one y, and meaning value. Okay, so each x value has only one y value. Okay, and remember that a function can be expressed in many ways: a graph, an equation, a table of values, or even in words like a word problem. You know, Johnny makes $5 per hour plus a $5 bonus. Okay, we could write that in an equation. Okay, and test to see if it's a function or not. Now, when we do with functions, we always talk about the limits. And the limits we take a look at are the domain. So the domain is a set of the first elements in the relation, and usually we're dealing with x. So how far left and how far right does my function go? Likewise, the range is the set of all second elements, and second elements are usually the y, especially if you're looking at a graph, and y deals with the up and down movement. So how far up can things go and how far down can they go? That's a common thing when you remember when you did quadratics, the maximum minimums, those were the limits for your ranges. Okay? All right. Now, remember that a relation can be an equation, or can it be a set of values or set of data? We're going to take a look at both cases here. So here's an example. Determine if each relation is a function and state the domain and range. Well, first of all, notice that we're given a set of ordered pairs. All that does is translate into a table. So if I want to go 0, 2, 1, 3, 2, 4, and 3, 5. Looking at our table, does each x have only one y? Yes, it does. Okay, so that will prove that it is a function. Another way you could do is graph it. Okay, and you might remember something called the vertical line test, which we will discuss in the next page if you're not sure. Okay, but taking a look at our graph, if you plot these points, ladies and gentlemen, you've got 1, 2, 3, 4 there. Notice I don't join those dots together in a solid line. Notice that they are in a dashed line because they are not continuous. Those are what we call discrete. Okay, this could be an example where you order like number of books and the cost for number of books. You couldn't really order 1.2 books, right? Okay, so for discrete data, you show a dashed line. If it's something that's measured, like you can measure the height of a plant over time, then yes, you could have like 10.5 centimeters as a height or 8.2 centimeters as a height. So that's when it would be continuous and you would draw a solid line. All right, so let's keep going here. Is this a function? Yes. Use the short form for because. I'm okay with that. Because each x has only one y value. Okay. When we go to take a look at our domain and range, in this case we use capital D, and domain deals with the first set. And we notice that these are ordered pairs, so we're just going to list the values in order. Okay. If they happen to repeat, then you don't need to repeat them. Okay, and you go in numerical order. For the range, we take a look at the y, or the second, so it goes 2, 3, 4, 5. All right, good. Now we're going to move on to the second one. Again, we've got, for B, we've got a set of ordered pairs, so let's put that in the table. And I always put it in the table because it's a better visual for me. Okay. Looking at this visual, does each x have its own y? And where I get stuck is right here. When x equals 2, what happens to y? Y equals 4 and 5. So does each x have only one y? In this case, no. So does this mean this is that this relation is a function? No. Okay. And so I would say no, because when x equals 2, y equals 4, and or you could say either one, 5. Okay? Or you could also say because each x does not have its own y, because y has two parts here. Okay? Another thing to remember, guys, vertical line test, we're going to do on a separate sheet of paper or on the next page. You could take a graph or take a vertical line, and as you go left to right, and if you put, just a second, I'll show you. I know it's coming, so here, I'll just make a straight line here. So pretend this is my vertical line test, which I'm going to show you on the next page anyway. Notice as you go left to right here, it's fine, it's fine, it's fine, it's fine. But here, right, oh, come on. Please move over. Right there, ladies and gentlemen. Notice that there's 2 points. That's telling you that when x is at 2, y has 2 values. So that makes it no longer a function. But again, save that for next page. You could also use that as a valid reason here. I would accept it too. All right, dealing with your domain. Domain is taking a look at your set of first variables. So you go 0, 1, and 2. Notice here, folks, that the 2 is not repeated because it's already included. Okay? When you do the range, on the other hand, has more values. It's another indicator that usually it's not a function if you have different number of domains as ranges, as long as it's each x has its own y. I've seen the opposite where 2y, there's two x's share the same y. That's different. Okay? All right, let's move on to the next page. Now we're going to take a look at that vertical line test. It's a quick visual way to determine if the graphs represent a function. If the vertical line intercepts the graph 2 or more points, then it is not a function because it has 2 or more output numbers. That means each x does not have its own y. So for this example, now we're dealing with graphs. Determine if each relation is a function. Explain and state your domain and range. So again, I'm going to take my vertical line tester, I'm going to move it right across, and as I go from left to right or right to left, doesn't matter, you will notice that at each time only the relation in red will touch my green line at only one point. So then you would say, yes, this is a function because it passes the VLT. And you can use that on the test for short form vertical line test. Okay, my domain is going to look different. Notice I don't have a set of points here, but I actually have a solid line, which shows me I've got a relation. So this is where we get into some funky writing. Domain is that x belongs to a set of real numbers. And we can look for any restrictions. As I keep going left, or as I keep increasing x, what's happening to y? It keeps increasing. So there's no limit as I go to left as to right, so it's just x belongs to a set of real numbers. Same with the range. The range, okay, as I go up and as I go down for the range, I can keep going up as this function. Remember, this function is going to keep growing and growing, so it's going to keep going up, up. Likewise, in the other direction, it's going to keep going negative and more negative and negative. So the range is such that y belongs to a set of real numbers. If you're worried about that terminology, please come and see me. Just remember that the brackets indicate what you're looking at. X is the ordered pair or the element you're looking at. This is a symbol, a Greek symbol. It's an E that means belongs to, and R is capital for real numbers. Okay? And real numbers encompass decimals, fractions, positives, negatives. Okay? All right, taking a look at the second one, B. As I take my vertical line tester and I go from left to right, you hopefully recognize B as a parabola or from a quadratic relation. And notice as I go from left to right, it still passes the VLT. Even if I try to extend my graph, it's still going to keep passing it, right? Okay. So is this a function? You will say yes, because it passes the VLT. The domain. So how far left can I go and how far right can I go? Well, as this keeps growing, it keeps going from negative infinity to positive infinity. So what does that tell us? That, oopsie, that's a funny looking bracket, there we go, that x belongs to a set of real numbers. That means there's no restrictions. Keeping an eye here on the range, things are a little bit different. As I go up, there's no limit. But there's a problem when I try to go down, ladies and gentlemen. I'm stuck. And that's where you're at the minimum in this case, because the parabola opens up. So we have a minimum value. So that's a restriction. So we start off with that y belongs to a set of real numbers, such that, that's just a straight line, meaning here we're going to tell you a restriction, such that y has to be greater than or equal to 0, because it's sitting right on that right on the origin there. Okay, so remember, this states that, hey, we've got a relationship, but there is a restriction, and that's that y has to be greater than or equal to 0. Great. All right, let's keep going here. All right, so for C, if I take my magic wand and go left to right, what do we notice, folks? Every point except right there, for every other point, it's hitting my vertical line stick at least 2 points. So no, this is not a function because it does not pass the VLT. Okay, my domain, okay, it is how far left and how far right. I have no trouble as far as I go right, but I can't go left, can I? Because I'm stuck right here. So again, we start with x belonging to a set of real numbers, such that x has to be what? X has to be greater than or equal to 0. Okay? Looking at my range, as this still continues to grow, still going to go as far up as it can and far down as it can. So there's no restrictions on y in this case. All right. Last graph. Let's use our vertical line test. You recognize this as a circle, and indeed a circle is not a function because it does not pass the VLT. So let's write that down. No, this is not a function because it does not pass the VLT. Okay, our domain, we've got to be careful with this one. It says this is 5, and if we know this is a circle and it's centered, that's 5. My lower limit, or my smaller limits, are going to be -5, as long as it's centered on the origin like it looks like. We've got to take a look here. So for my domain, I can start and go to the right, however I'm stuck at 5. Same as I go to the left, I'm stuck at -5. So when I write that, I say x belongs to a set of real numbers such that my smallest value or my minimum value can be -5. Has to be greater than or equal, or less than or equal to x, which has to be less than or equal to 5. So I put my minimum first and then my maximum last. Okay? We do the same with our y, or our domain. Or our range, my fault. Okay? As we go to our lower limit, we know, first of all, we've got a relation because it's a solid line, but our lower limit is -5, our less than equal to y, less than or equal to 5. And closing brackets. All right, now we're going to take a quick moment and take a look at equations. Those are harder to tell, okay? But I want you to use this key to help you with success. When given an equation, visualize, try to graph it. So looking at E, what does this equation tell us, ladies and gentlemen? Well, first of all, you should recognize that, hey, it's a quadratic. And the base quadratic is y equals x squared. But what have we had to do with it? Add 4. So all I'm going to do is take it and add 4, which tells me that my minimum is at 4. Okay? Again, we could use a vertical line test. And as we go left to right, we see that it is a function. So yes, this is a function because it passes the VLT. And the domain. Domain is, for any quadratic, the domain is such that x belongs to a set of real numbers. Okay? But the range, got to be careful with the range here, folks. What do we know? We know that we can keep going up and up and up, but we're limited as we go down. Look at the minimum. Sorry about that, guys. The minimum tells us that we have a restriction there. So y belongs to a set of real numbers such that y has to be greater than or equal to 4. Great. Okay, last equation. This is a tricky one. It's got x squared plus y squareds, and it's got to be equal to 121. Hopefully you recognize that from this formula, x squared plus y squared equals r squared. Okay, that's the formula for the circle. So what do we know? R squared equals 121. R represents the radius, so to find the radius, take the square root, and the square root equals 11. So when we draw our circle, and it's centered around the origin, oh, that's not bad for a circle. We notice that we got 11 for our maximum, -11 for our minimums. Okay? Once we can visualize that, hey, is a circle a function? No, because it does not pass the VLT. Okay. And what do we know about our domain? Okay, our domain is our left-right movement. So first of all, we know since we go out a solid line that we're dealing with a relation such that our minimum is -11, is less than or equal to x, which is less than or equal to our maximum value. And that's the same for y. So when you've got a circle, you're going to have the same restrictions on both variables as long as it's centered at the origin, which in most cases it is. All right. Moving on, we're going to deal with the last thing is mapping diagram. So a mapping diagram shows one value with its associated value. So these are in circles, so this is what you call a mapping diagram. It's very similar, ladies and gentlemen, to a table of values. So if you want to think about it, this is the X and this is the Y, go ahead and do that. Okay. And we want to, the example say, state whether or not the mapping diagram represents a function and write the domain and range for each. Notice the mapping diagram is not a relation. It's not going to be a solid line when you graph it. It's just going to be several points on a graph. So you're going to be listing the ordered pairs. Okay? So just remember, if that's the X, this is where we're looking at for our domain information. And this is the Y, so this is where we're looking for our range information. Okay? So let's take a look at the first one. Does each X have its own Y? Okay? So taking a look, each X has its own Y. So yes, this is a function. Only one Y. Okay? You might be wondering about this kind of scenario right here. Okay? Notice that the Y has two X's, but that's okay. That's not part of the restriction. Each X has to have its own Y. So yes, this is a function. To do your domain, oopsie, that's a funny looking D. So our domain, and you list your values in order. So 1, 2, 3, 4. Okay, and our range is 5, 7, and 9. It's okay for Y to share two X's, but not two X's to share one Y. Okay? All right, taking a look at the second one. In this case, does each X have its own Y? I'm going to look right here, ladies and gentlemen. This X, so when X equals 4, we have Y equaling -9 and equaling -6. So that should give us a key indication that no, this is not a function. So no, because when X equals 4, Y equals -9 and -6, or you could say because each X does not have only one Y. Either answer is fine with me. This one just gives you more specific details on it. Okay, so dealing with your domain, list your numbers 4, 6, and 8, and your range -9, -6, -3, and 0 going in order. And again, notice in this case, folks, when the domain has less values than the range, in most cases, that's when it's not a function. All right. There we are, folks. That's our lesson for today. Here's your homework, page 82-83, numbers 3, 4, E, F, G, H, 6, 7, and 8, A, B, C. Have a fabulous day and enjoy this new unit. Have a good day.